Okay, so in 2022, there was a really interesting poll done that showed that in your enterprise, on average, there are 184 microservices. So in our next talk, we're actually going to discuss, for example, if you want to change a critical process in one of your services, or if you would like to introduce a new service to your existing microservices, how you would do that. So Samantha, please come on the stage.
Give her a round of applause. How many of you are orchestrating chaos right now? No one? Okay, I see 2 hands. Just 2? Whoa.
There was a hand and a half, it was like this.
Well, that's nice. All right. So let's see. All right, here we go. Sorry? Yeah, sure. So let's see. I don't know how many of you are thinking, well, we talked about scraping. Now we are talking about orchestrating. Are we kind of trying to build a startup here?
Actually, yeah, I think we can start a startup with everything involved.
It could be.
Yeah.
We talk about funding, we talk about how to reach communities, so it could be interesting for you guys looking for a job, actually.
Yeah, true.
Or to find chaos. All right, so we are leaving you the stage. Stage is yours.
All right.
Good luck.
Thank you very much.
All right, another round of applause.
Hello there. Thank you so much for having me. I am super excited to be here at Open Source Day. This isn't my first time in Italy, but it is my first time in Florence, and I do have to say, this city is absolutely beautiful, so I'm happy to be here. Like I said, we are going to be talking about process automation in our modern architectures today, so let's jump right into it. So I know that you guys are a little timid today, a little shy audience, so we're going to break out of that. I'm going to learn a little bit more about you all first with a quick poll. So if you don't mind raising your hands, how many here use microservice architectures? Okay, a big majority of us. Awesome. All right, so next, has anyone struggled to explain either data flow or logic between either or both technical or non-technical teams? Yeah, I know, it's a struggle, right? Almost all of us. Perfect. All right, third question. Has anyone here heard of BPMN, DMN, or BPM? Okay, we actually have a few. That makes me excited too. We're also going to learn about that today, so don't worry about it. And then lastly, has anyone here heard of Camunda? And not just because you saw the name on the title slide here. All right, okay, we actually have a few. Again, that makes me really, really happy. Cool, so by the end of this talk, you will learn how to explain what BPMN is, oh my goodness, my words, what a process is, and how these can be used in your microservices architecture. So now that I learned a little bit more about you, let me quickly introduce myself. Again, my name is Samantha Holstine, and I use she, her pronouns. I have a background in software engineering, and I am based in Denver, Colorado, United States, but I have lived in the state of Colorado my entire life. And a fun fact about me is that I teach dance fitness and studio rowing in my free time. So if you like to dance, if you like to row, I'd love to chat about that afterwards. And lastly, of course, I'm a developer advocate at Camunda. So for some of you who know what Camunda is, yes, process orchestration is what Camunda does. But this isn't going to be some sales pitch where I try to get you all to purchase, our product and use us. I'm trying to get you all to think about solving your problems in a different way. So, a little bit more audience participation here. What is modern software architecture? Can anyone just shout it out to me? What do you think? Oh, come on, don't be shy. Anyone want to take a guess? No one? Okay. All right. That's okay. Talking is a little bit too much other than raising our hands. That's okay. So with our modern software architecture, we need it to be all of these things that you see on the bubble on the screen, right? We need it to be reliable, we need it to be testable, observable, scalable, agile, whether you like that word or not. We need it to iterate quickly, and we need to be able to fix those bugs and keep moving forward at a rapid pace. And we wanted to have all of these things mentioned, but how do we achieve that? So one way that we solve this issue is using a microservices architecture. So the majority of us raised our hands when I asked you if you already used microservices architecture. And as an industry, that norm has shifted from using a monolithic architecture, where all of the data, the business logic, and the UI are in a single code base, to one with microservices, where there are multiple small independent services that communicate over well-defined APIs. And the point that I am leading up to here is that modern architecture is about the infrastructure. It's great at optimizing resource usage. It's great at lowering costs, scaling up when you need it, scaling down when you don't. But now, try to explain it. Going back to that question in the poll that I asked you about talking to those non-technical teams or even other technical teams. Someone on the business side of your company comes up to you and asks, what's the process to fulfill an order? How does data get from A to B, and what happens in between? Or maybe you're trying to onboard a new person on your company and you're explaining how your product works. What are the steps in order for the product to work? What database does it need to talk to? What service does it go to next? Now, try diagramming it. So you take them through your service. Well, they're going to click here. It takes them to microservice number 1, which connects to a subsystem microservice that fetches this data, but then also something else happens over here. This is running in parallel. And honestly, it kind of looks like spaghetti thrown up on a whiteboard. And the person who asked you says, I don't care what service or API or whatever is actually responsible for this. I care about what happens when someone presses the order button. And it's really hard to diagram data and logic flows using an architecture diagram. You ultimately end up with a list of dependencies and relationships instead of a meaningful picture of what happens when a user takes action. If you're working that way, the documentation is going to be a nightmare. Adding timers for alerts, or stuck processes, or notifications if something is taking too long is doable. But these solutions are not very elegant, and they're really hard to troubleshoot and debug, and it's usually not super fun to work with. Interrupting messages. You're already doing something, someone already submitted an application, for example, and now you need to make a change to it. How easy is that to do? Again, you can do it, but the solutions are usually not the most friendly, and it can be really annoying to implement, and they're certainly not enjoyable to maintain. And then, of course, once you get everything working, someone will come with a new requirement, with a new change, with a new addition, and at that point, you might have to go back and rethink everything. The theme is difficulty here. So instead of thinking about the services and the architecture, let's think about this in terms of processes. So what is a process? The dictionary defines a process as a collection of related, structured activities or tasks performed by people or equipment. And we are talking about the business logic that happens in your application. So let's look at an example here that we're all most likely familiar with, a loan application. So you have to submit an application, it gets reviewed, maybe they check your credit score, do a background check, and you eventually get to an approval, either yes or no. And when they say yes, then they are going to have you do some paperwork, they'll disperse the funds, and then you start getting those bills and you have to pay the monthly fee. So even if you're not familiar with that loan process, we are all familiar with a process that goes step by step, right? But how are you going to implement that in code? Let's look at a real-world scenario. Local municipalities need to issue permits for trucking companies to drive through. In the EU, I'm assuming we have something similar as we do in the US, but in the US, usually the trucking company fills out a form, a price is determined for the permit depending on how big they are and where they're going. The company then pays for the permit, and then the permit is issued so they can drive down the street, they can go into a weigh station, do what they need to do in that municipality. So let's think about this in terms of microservices. We have some sort of front-end service that displays the form. Once that form is submitted, we match it to the permit that makes sense for the size and the location. Then we have a way to submit that payment. And then once the payment is accepted, then we issue that permit. So remember, this is a simplified example with 4 microservices, not 184. Which we can make a visual representation of that permitting process. Note again that it doesn't yet matter what our actual microservices infrastructure is, just the steps that need to get done. So has anyone here used like Visio or Lucidchart or any sort of visual diagramming service here? Yeah, right? This is what it looks like, right? Oh, but wait, we have a new requirement. The permit needs to be turned into a PDF, and we need to email notifications to both us, being the municipality, and to the user, being the trucking service. Okay, cool. We're going to add 2 new microservices that we can call, one for generating the PDF, and another for sending out those emails. So on our diagram, after we issue that permit, we are going to generate that PDF, email the user, and then email the municipality. Okay, pretty simple, right? Makes sense. Oh, wait. A new requirement just came in. The stakeholders came back and mentioned that someone tried to fill out a form that didn't match to a permit, and we need to fix that. Okay, so now we need to have some manual validation here for when they submit that application, and then we'll go collect that payment. Or if there is no issue, we'll just go straight to collecting that payment. Pretty simple. Oh, wait. Another new requirement. If they don't pay in X number of days, then the permit needs to be canceled. Okay, so that's on this step right here in the green. How would you implement this? You could go back to the code, create some sort of scheduled cron job to check all the current permits that you have, see which ones are stuck at the payment step, see how long they've been there, maybe cancel after X number of days. It's not really straightforward, and there are really many ways to think about it. So this is where I introduced to you my friend from earlier, BPMN. That stands for Business Process Model and Notation. BPMN is a maintained spec from OMG, the Object Management Group, and its distinguishing feature lies in its capacity to visually articulate complex processes clearly. And it's really easy to simplify those discussions with stakeholders, enabling a more effective, streamlined communication process. So right here is a classic example of a BPMN diagram about ordering a pizza. As you can see, it's much more complex with all these different symbols and lines and different sections on here, and I'm not going to talk about all of those specifically. I just want you all to get used to the idea that BPMN is that spec that defines how data moves through a system. So let's go back to our truck permitting example. This is what our diagram looks like in proper BPMN notation. So like I said before, this isn't a BPMN 101 class. So I'm not going to dive into all the details here, but here are the important things to note. We have a start event and an end event, those circles on the left and the right-hand side of the diagram. And as you notice, all of the arrows go back into those gateways, that diamond shape, just because that's semantic BPMN. So remember this. How can we solve this using BPMN? We can actually just add a timer event to the collect payment step. So if they don't pay in X number of days, we cancel their application, and then the process ends. Okay, so I can see it on some of your faces. I can hear you all now. You're saying, that's great, dude, but that's just a diagram. You literally put a clock icon on top of a square. Or is it actually just a clock icon on top of a square? Allow me to introduce you to the world of BPMN engines. It's XML under the hood, so it's executable. You're not only modeling and visualizing your business process, but you're able to easily implement and automate it as well. You can also check it into source control, and BPMN is a standard, so you can count on that predictability. That notation is not going to undergo arbitrary changes and have all of those weird nuances accumulated over time. So this is why BPMN matters. Because it is XML, and because it is an open standard, you can execute a BPMN model with a BPMN engine, also known as a workflow management system. And it may surprise you to learn how many BPMN engines there actually are. I can tell you I was genuinely shocked when I joined Camunda. And from my experience, at least in the United States, this is not how we think about software architecture at all. So I'm not here to tell you that there's a single platform, a single company, a single thing that can solve this problem, because as you can see right here on the screen, there are dozens. But since Camunda is paying for me to be here, here is a short overview of what we do. Now, I promise this will be one slide, and then we'll go actually back to learning. So unless you want to hear a little bit more afterwards and come talk with me, this is all you're going to hear about it. So our vision at Camunda is to be a universal process orchestrator for complex business processes that span people, systems, and devices. We give you the power to automate any process anywhere so you can transform your organization toward a digital future where you're delivering a better customer experience with short time to value, more business agility than ever, and increased operational efficiency. We can help you get there by using open standards to help IT teams and business stakeholders collaborate, giving software developers the flexibility to use their preferred programming languages, tools, and practices, and providing connectors that orchestrate processes across endpoints, and doing it all at scale to support your growing business. Okay, I promised one slide. It was really short. All right, we'll go back to actually talking about this and learning about this now. So let's look at our process and talk about how to actually make it run versus it just being a model. So if you didn't notice earlier on the diagram, each rectangle, each task has a symbol in it now. So first we need to define the icons that you see here. The gear icon in the green circle means that it is a service task. These are tasks that call out to some other service. And then the person icon in the blue circle means that it is a user task. This requires human input, which is actually supported by the engine. So if we add in those service calls to our example, it might look like this. As you can see, all of our tasks here are set to our specific service, except for our email tasks, which are connected to the same email service. Either way, this is much less like spaghetti than our original diagram, right? So how does the engine know how to call the permit match service, for example? Well, that's the best part. It's entirely up to you and how you choose. Exactly how you implement it may vary depending on the engine that you use, but if you choose Camunda, you have three primary options. The first one is a job worker. A job worker is a piece of code that you write that runs in your environment that performs a single task. The second option is a custom connector. So a connector is like a reusable job worker with predefined inputs and outputs. And the last option is a RESTful API call. So a REST connector is provided out of the box with Camunda, allowing you to make all of those REST calls without writing any additional code. So another important thing to note, The state of a process is managed by the workflow engine, not the application. The data is managed by the application, not the engine. So what the workflow engine cares about is where an application is in the process, and what the applications care about is the data that they're managing. So let's add a new requirement. The stakeholders come back and say, some permits need additional approval before collecting payment. That's actually pretty easy with BPMN. Let's zoom in on our process and make another gateway. This time it's an exclusive, also known as an XOR gateway, meaning that there's a decision to be made and the process can only choose one option. Now, right here, we have a gateway for whether or not they need additional approval. And if they need additional approval, we go and get that human validation right here, a user task, before continuing. And again, we don't have to write any code to update this process. Just add this step since it's a user task. So, yay, here's our whole process zoomed out. We start with that start event on the left-hand side, where the user submits the application form. We then go and match that permit and get the fee. Now, if there is no match, we go and get that manual validation from a human before we continue on with that process. And if there is already a match with our permit, we continue on. We then check if there is additional approval needed. And if we need that additional approval, we will go get it again from a human before we move on. And if there is no additional approval, we then go straight to collecting that payment. After we collect that payment, if it hasn't been collected in X number of days, we are going to cancel that permit and end the process. And if the permit is paid for in a certain amount of time, we are going to then issue that permit, generate the PDF, email the user, and then email a municipality. And then our process ends. Pretty simple, right? Oh, wait. There's a new requirement. We should probably send a payment reminder before we cancel the permit. Now, what's great about adding another email reminder is that it uses the existing email service that we already have hooked up to our process. So none of this is net new code. At most, you may have to set up the email template. So let's look at the green circled area here on the right of our diagram. To meet this new requirement, we can add another timer event. Now, the processes will stop until the next event is triggered. And if it isn't, then we will send that payment reminder before we cancel the permit. That's what those dotted lines around the clock mean. And again, all of this is reusing that email service, so we don't have to code anything else. Okay, so this is your redeeming moment as an audience for some audience participation. Are you ready? So I changed one thing on this model here. Can anyone tell me what I changed? Just go ahead and shout it out. You can raise your hand if you want. Go ahead. Yeah, like right here? Yeah, exactly. Good call. Good job. Give them a round of applause. Yes. Good job. You have redeemed yourselves as an audience. Good job. So I changed that first task, like he said right here, a bit on the left in the green circle. So just while we're here, we can talk a little bit about error handling. So remember that manual application validation that we did at the beginning? Now, we can clean up that first task to add an error catch, which tells our model to follow a different process if we encounter a problem. So if we run into that error at the permit matching stage, the process will match the application with a human to do that manual application validation before we continue with the rest of the process. Wow, that was easy, right? So let's review what we talked about today. First, BPMN is an open spec that defines processes in an organized, understandable way. BPMN engines execute the processes as modeled, connecting all tasks to external services, and the state of each process is controlled by the engine, not the application. And lastly, processes can be modified, changed, deleted, added to, and sometimes without changing a single line of code. This makes it understandable not just to engineers, but all stakeholders as well. So if you are interested in learning more about BPMN, here are a few resources to check out. Camunda has some awesome tutorials and lessons about BPMN on Camunda Academy, as well as our code studio on YouTube. We also have BPMN documentation on our website. And also, I encourage you to check out our forum, where there are further insights to BPMN and community collaboration as well. So thank you so much for participating and listening, and I hope you guys have a lot of questions.
Whoa, 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 whoa. That's a game changer. So thank you, first of all, for this great talk. And Irene, it's your honor.
It's your time to receive the
So excited.
trophy.
Thank you. Yay.
All right, so we are on time, so full of questions. Are there any questions? Yeah, right there. I'm going. How can I reach you? Oh, it's a battlefield.
Thank you. Great talk. This is my first time hearing about this, and I'm really interested. Hopefully, you can chat after the whole question bit.
Of course.
Can you nest processes?
Yeah, you
Like
can.
have a whole bunch of processes, and then those processes call another.
Yeah, so basically we have what's called sub-processes. So you're able to have a process call a whole bunch of other processes, but without making them look, like you have this big giant tree in front of you. So you can have your main process call another process, so then they can be nested and they can be called simultaneously as well. And it's just not as, I guess, large looking. So you can kind of really nest as many processes as you'd like into your process.
Okay, cool. Thanks.
Thank you for your question. All right, I see another one.
The next question is here.
All right.
Thank you. Since this BPMN standard is, in this case, we are talking about it from the perspective of microservice system, but it's basically a language, let's say, for organizing processes. Can this be adapted to other way of producing software, for example, like even for monolithic system, by just like considering instead of like services maybe part of a program?
Yeah, totally. You can
And
model.
also, do you think if there is like any pitfall to using it for something that is not like strictly related to what you told until now?
Yeah, definitely. So yeah, you can definitely model just a certain part of your application, a certain part of your code. Again, if you're not using microservices, you can still definitely model out everything that you want to do and hook it up as well. And honestly, I think that there is definitely a need to model, even if you're not modeling your microservices, if you're not using a microservices architecture, just because of that really easy way to understand what is exactly happening in your application. So then you can have a little bit more freedom to be able to explain it to everyone instead of, kind of sifting through your code and being like, well, this happens here. Oh, hold on, let me jump over here. You already have it laid out, so then you know exactly what's going to happen where, if that makes sense.
Thank you.
Any more questions, guys?
Yeah, here.
Thank you. So first of all, thanks for the talk, because it was very interesting. So it popped up in my mind a course which I followed in my studies. So what I want to ask you, like I knew Camunda beforehand, but I didn't. I've never used BPMN in a professional way. Mm-hmm. Is there any way to model like I don't know, fairness properties inside the tool you are proposing? Like if, for example, there's a violation of a safety property or something like that, does it come up immediately if I model something which is not allowed, which is bad? I don't know if you
Yeah.
if the question is clear.
I think so. So what you're asking is basically like if you're modeling something that doesn't work, if that's correct?
If it doesn't work, yeah.
Yeah. So if the model
less.
doesn't work, then yes, we have those checks when you run it in place. You're also able to see exactly on Camunda where like you are at in your process. So you can see, for example, if you're on a specific task and that task fails, whatever you send back to Camunda, maybe to move forward, any sort of information will pop up there. So you're able to go in and say, oh, that doesn't look right. Or again, you can have those error catches. You can have, different paths and gateways to make sure that if there's something going wrong, you can go and fix it. So there's ways to be able to go in and correct it, as well as, so if you're running your process, there are ways to also go back like a step or two. So if you know that something is happening and it's not what you're wanting to produce, you can go back, fix it, and then go back a step in the process. You don't have to start it over as well.
Okay, and just a quick follow-up. How do you model fairness in the process? I mean, for example, if you have multiple paths in your process,
right.
How do you model inside the tool? I mean, what percentage, for example, if ever, of executions go that way? I don't know if the question is clear.
I think so.
This is a transition system, right?
Right,
You're
so
modeling a transition system.
Okay,
more
so
or less.
basically you're asking about like the statistics of like if you model something, then like what is the statistics if like it's going down a specific path, if that's what you're asking for?
Yes, I mean maybe it's not supposed to go to that specific path, but it should. How do you model, like in your visualization at the beginning?
Right.
You have like the dots, like if it's a transition system.
Yeah.
How do you model the percentage of things that go one way or the other? It's just
right. Yeah. So again, you can model your process however you want to.
Okay.
So you can go and have like 5 different branches, for example, of, okay, I really wanted to go down this main one, but if this goes wrong, it'll go here. If this goes wrong this way, it'll go here. And Camunda does have some tools that show those statistics as well. So it's called Optimize. And Optimize goes in and it has a lot of heat maps and dashboards where you can say, hey, so with this start event, I want to see how many times my processes go down this error route. You can go and you can see those specific examples, those specific processes, instances, so you're able to really see exactly where it's failing or where it's going down. So there is that way to check.
okay. Thank you. Thank you so much.
I like how this Q&A session is going because it's kind of an open discussion. So are there any other questions remaining? Don't be shy. Here.
So, thank you for the speech, of course. And I was wondering, this seems like airflow to me, like from a data engineering perspective. And I was wondering, is that only a UI part and there is like a coding part underneath? Or you do all just by drag and dropping stuff?
Right, so we're not just drag and drop. So we are low code. So what that means is you can go in, you can do that drag and drop if you want to and stay at that level only. But if you want to add code, you can add your own microservices, so hook it up. Or we also have within our modeler where you're able to add some pieces of code of how you're running it. For example, how the model is going to go in certain directions as well. Does that make sense?
Yep.
Okay.
Thank you.
All right. So I think we can round it up. As there are no questions left, I believe. If there are some questions left, please find Samantha here for the rest of the day and for the aperitif as well. So give her another round of applause for the talk.